Welcome to Catastrophic Science, where we unveil life-saving research that has resulted from catastrophes. The terrorist attacks on the World Trade Center resulted in it collapsing with surprising ease. More than 2,700 people died. How to better construct buildings and prevent loss of life has occupied engineers ever since. UNSW engineers have been working on the effects of heat on steel, high-performance concrete, and blasts in the city environment.
In the case of the World Trade Center, the collapse was due to the design of the building. They had very, very stiff beams, because they're very long beams, spanning right from the lift core in the building out to the perimeter columns. So you didn't have internal columns that are going to compromise the ability to rent floor space. The impact of the aircraft itself would have knocked the fire protection off. And so when you got expansion of those beams in fire, they pushed against the very, very flexible columns and knocked the columns out of alignment, and eventually that led to the collapse. And as a result, of course, they don't design buildings that way anymore.
Fire research found that using less rigid steel beams, supported by columns at regular intervals, was preferable. The beams buckle and sag, but the columns hold them in place.
We've shown that because you get this sagging taking place and it's allowable, that you actually don't need fire protection, which can be up to 30% of the cost of the steelwork. So that's very substantial.
That's quite a saving.
Yes, and the groundbreaking research that we've done is in the connections, because we have to make sure that the connections are robust enough when you've got the fire acting on the structure to be able to hold that beam in place so you don't get failure. It keeps the fire in a compartment and it allows the occupants to get out of the building.
Now, this isn't the first time that terrorism has played a role in affecting future engineering. Since the 1995 Oklahoma bombing, where 168 people died and more than 680 were injured, researchers have been working on ways to allow buildings to be evacuated safely before a controlled demolition.
We've been doing a lot of work on what's referred to as ultra-high performance concretes. Now, this is a concrete that is typically about twice as strong as conventional concrete, but it is also between 100 and 200 times tougher. And that means that it can absorb 100 to 200 times more energy and still resist the loads and hold the structures up. It's probably twice as expensive as conventional concrete, so you just need to identify what the most important structural elements are. For example, ground level columns in important buildings. And we've also been working on what's referred to as progressive collapse of structures. That's very much how a structure behaves after the removal of a column in the course of a blast. How does the structure then perform to protect itself from that event and the area of damage? What we learn today will be utilised by engineers in the future.
Brian, you've got an exciting job. You actually just get to blow things up.
Yeah, part of my role is to carry out blast testing on structures to see how they fail. Computer simulations, which a lot of people do, are not always that accurate. There's a major emphasis on looking at blast from an industrial perspective as well, from mining and oil and gas industry.
And this area of research is gaining momentum. There's a new centre, I understand, being built.
Yeah, we have a national facility for physical blast simulation, which is being built at UNSW, and we'll be able to carry out blast simulations for city environments. One of the issues that we would like to understand is if a blast is triggered in one part of the city, when those waves propagate through the city, they can cause reflection and they can increase the intensity of pressure in another part of the city, and we want to be able to understand where those vulnerabilities lie. Ultimately, if we understand the entire blast phenomena, public safety will be improved.